Alright, ladies and gentlemen, we are doing 8.6b, speed, velocity, and acceleration. We are differentiating between those three words. You have your Cornell notes that look like this. It's slowly loading. Sorry that it's sideways, but you get the gist. Alright, so here's our TEK. We are differentiating between speed, velocity, and acceleration. Keyword differentiate. We want to tell the difference between speed, velocity, and acceleration. All right, our first essential question off to the left asks us, how does one identify the speed of an object? Well, speed is how fast an object is moving is called speed. How fast an object is moving is speed. So whatever this water contraption is here is going so many miles per hour or so many meters per second. So that is its speed. Next in the middle, it also says that speed is how far something travels, which is your distance, in a given amount of time. So speed is distance over time. The next thing it asks you is the formula for speed. If you remember our density formula, we had a triangle. So you need to draw this where it says what is the formula for speed, which again, speed is distance over time. In the speed time triangle, the distance is always going to be on top. The D is always on top, the S is on the bottom left, and then the T is on the bottom right. So again, speed equals distance over time. Alright, the next thing is the unit for speed is meters or kilometers as a distance, and seconds or hours for time. Then it asks you, what does it look like? Well, it looks like this. You have meters per second. M is meters, not miles. Miles is MI. Or you have kilometers per hour. So make sure you write those down for where it says, what does it look like? Then it asks you for an example. Well, here is an example right here, 11.2 kilometers per hour. So it would look like this, 11.2 km per HR. 11.2 kilometers per hour. Alright, our second essential question asks us, how does one determine the velocity of an object? So velocity is the term used when referring to the speed and a direction. So velocity uses our first word, speed, and the only thing we have to add is a specific direction. The next blank is vectors can be used to show the direction of an object's motion. So for example, if I was going 40 meters per second north, north will be straight up. That's a vector. Alright, then it asks you, what is the velocity formula? Well, velocity is speed plus a specific direction. Then we take the same formula. Speed equals distance over time plus direction. Speed equals distance over time plus direction. Alright, so now we need an example for a velocity. Okay, so here is a random person. They are traveling 53 meters per second. And in order to make this an example of velocity, I need a direction. Well, they are clearly traveling to the right. But if we're talking about direction, never eat soggy waffles. That means they are traveling east. So my velocity is 53 meters per second east. Alright, lastly, we're talking about defining an acceleration for an object. Alright, when a force is applied to a moving object, the object can be accelerating by speeding up, slowing down, stopping, or changing directions. Those are your blanks. Alright, any change in motion of an object is called an acceleration. I don't know why it's on there twice, but it is what it is. So any change in motion of an object is called an acceleration. This next part is very important. Acceleration is measured in meters per second, or meters per second squared. That is something I need you guys to always remember. Acceleration is always meters per second squared. If it is just meters per second, that's a speed. Meters per second squared is the unit for acceleration, always, never changes. Lastly, it says name 5 examples of acceleration. So here's our first example, stepping on the brakes. Example number 1, stepping on your brakes. If you step on your brakes, it doesn't necessarily stop the car, but you are slowing down, so that is a change in motion. Example number 2, pedaling your bike faster. You are speeding up. When you speed up in reference to acceleration, we call that positive acceleration. So pedaling your bike faster is the second of 5 examples. Number 3, dropping your lunch tray to the floor. So I'm holding my lunch tray, walking to my table. Oh, accident, falls to the floor, drops down. That's a change of motion. Number 4 is going to be a dog chasing its tail. So as the dog is constantly spinning around in a circle, his direction is changing, his speed is changing, depends on how tired he is or whatnot. So that is also an example of acceleration. A roller coaster climbing to the top of a hill. Now think about it. I'm sure many of you have been on roller coasters before, okay? But on this roller coaster, as you're going up, let's think about the speed, okay? Typically, when you leave the dock to get onto your roller coaster, you're kind of going at a good speed. And then as you start to climb, you go relatively slow. Okay, that's going to be a negative acceleration in that point. When your speed is slowing, because it's got to build up that potential energy, it's slowing down as it reaches the top. Okay, that's going to be a negative acceleration, but it's still acceleration. Alright, lastly at the bottom it says now summary, explain in your own words how these 3 physics concepts are different from each other. So let's just summarize them very quickly. Speed needs 2 things. You need a distance and you need a time. Example would be like meters per second. Meters is your distance, seconds is your time. We could do kilometers per hour. Kilometers is a unit of distance. Hours is a unit of time. Alright, velocity, speed needed 2. Velocity needs 3 things. Velocity is speed plus direction. So you need a distance. You need a time. And a direction. Okay, so it could be meters per second south. It could be kilometers per hour up, etc. And then acceleration is going to be any change in motion. So that's going to be stopping. Positive acceleration, which is speeding up. Negative acceleration, which is slowing down, or changing directions or turning. And ladies and gentlemen, that is pretty much it. Ta-ta for now.